Let's talk about a problem that is difficult to solve with the techniques that we've seen so far. But if we use a new feature of Java called repetition, it will be much easier to solve. Okay, so here's the problem statement. So what if we wanted to print a table of the squares and cubes of all the numbers from 1 to 10 on separate lines in the Java console? So how could we do this? Well, one way to do it would just be if you want 10 lines, numbers from 1 to 10, we put in 10 system out printlns with the data already in there. Okay, so let me go to my program here. So here's print a table of squares and cubes of the values from 1 to 10. Okay, so here's my first attempt, and I call this brute force because what I'm doing is each particular value here, like let's say for the line where the number is 4, I have pre-computed 4 and then the square of 4, which is 16, and the cube of 4 is 64. So I have 10 lines, 10 system out printlns, and if I run this, you'll see there's my table of the numbers from 1 to 10 and the square and cube of each of the numbers. Okay, so that works, but well, we're going to see there's problems. Okay, what if we wanted to increase the problem slightly? And I really like this table of squares and cubes. What if I wanted all the numbers from 1 to 1,000 with the squares and cubes? Oh boy, that would be way too much work because I would have to pre-compute everything in my head, and I'd have to put in 990 more lines to get from 1 to 1,000. Really kind of a pain. Okay, so what could I do here? Well, one thing is I'm using a computer. So why should I have to figure out what the square and cube is? Why can't I just have the computer figure that out, right? So instead of having the data built in here, 1, 2, 3, 5, 7, 10, what if I used a variable? And then I asked the computer to calculate the square and the cube of that variable. Okay, so that's going to be my second approach here, is going to be to use a variable to represent the number that should be the subject of each line. Okay, and then I won't have to do the calculation myself. So let's try that. Okay, so if I'm going to highlight these lines and make them into a comment, I'm using the little icon up here that changes all the highlighted lines into a comment. Okay, then I'll go down here, and I started to do this before the video started. So if I want to use a variable and have the computer calculate the squares and cubes, I'll declare a variable called num as an integer, and I will, what's the first number I wanted for the first line? It was 1. So I will store 1 in num. Then I will repeat the following. Okay, I will print the value of num, and then a tab, and then num squared, num times num, and then another tab, and then num cubed, num times num times num. Okay, so that would, whatever num is, that will print it and its square and its cubed. Its cube, I should say. Then, after I do that, but before I print the next line, I'm going to change the value that's in num. So num plus plus adds 1 to what was in num, so num was 1, and now it's 2. Okay, and then when I do the exact same system out println, see, that's exactly the same as the previous one, but the value of num has changed. So now I'm printing 2, and 2 squared, and 2 cubed. Okay, and then I can add 1 to num, so it's ready for the next one. So if I run this, right now I have 2 system out printlns, so I get 2 lines. But notice it's the first 2 lines of my other table. Okay, so if I want the numbers from 1 to 10, I could just highlight these 2 lines, copy, and then paste it in a bunch of times. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now I have 10 system out printlns. But the code is exactly the same. Okay, if I run it, ta-da, I get that same table. The numbers from 1 to 10, along with the squares and the cubes. Okay, so that's a little bit better than the brute force approach. Actually, you might argue it's worse because it's a longer program, and I still have all this. If I want 10 lines, I have to have 10 system out printlns. And so it still doesn't scale well. If I want 1,000 lines, I still have to have 1,000 system out printlns. I got to copy and paste it a whole bunch of times, and it's all the same, so that'd be kind of a waste of space. It's too much copying and pasting. Did I do it the right number of lines? I have to take some lines. I have to put some more lines in, etc., etc. Okay. So what can we do? Well, we could realize that if you look at this, what I'm doing is these lines, every pair of lines after the first two are exactly the same. I got system out println, the thing inside the parentheses is exactly the same, and I'm adding 1 to num every time. Okay? So instead of having to actually copy and paste this 10 times or 1,000 times, wouldn't it be nice if there was a way in Java that I could say, hey, take these statements and execute them 10 times or 1,000 times or until some condition is true? Okay, well, there is such a thing in Java, and that's what we want to talk about next. So attempt number 3 is we're going to use the Java while statement. The while statement in Java. Okay, to repeat a block of statements more than once. So I'm going to have those two statements, and I'm going to execute them more than once. So they're only going to be in the program once, but it's going to be executed a bunch of times. Okay. So here is how the format of the while statement. It looks very much like the if statement. Actually, the only difference is in the format is the keyword. So it starts with the keyword while, and then inside parentheses is a Boolean expression. Remember, this is it's a test that has a true-false result. And then inside a block of curly braces, okay, I have one or more statements that are going to be executed. Okay. Now the big difference, though, there's a huge difference in the meaning of a while statement as opposed to an if statement. If this was an if statement, if the expression is true, I do the block once and move on. If the expression is false, I skip the block and move on. But either way, I'm only doing it once. The while statement, the meaning is, when I first hit the while statement, I go and evaluate the Boolean expression. Is it true or false? If it's true, I execute the statements that are inside the braces, but then when I hit the end of the while loop, I go back and evaluate the expression again. So if the expression is true a second time, I do the block of statements a second time and go back and evaluate it a third time. So it's as long as the test is true, I'm going to repeatedly execute this block of statements. If the expression ever works out to be false, then I skip this block and move on in the program. So it's a way of setting up a repetition, and many times these are called loops, because what happens is I execute this test and do the statements, then I go back and do the expression again. If it's still true, I do the statements again, I go back, and so I have this round and around and around, okay, until finally the test is false, and I skip out and move on. Okay. So, how could I do that in my program? Okay, well, let's highlight this and make this a comment. Okay, so what I really want to do is I want to take this system out println and repeat it a bunch of times. And so here's my third attempt. Okay, so what I'm going to do is this. Okay, I know the number is going to start at 1 and grow by 1. So if I initialize num to 1, now here's my while loop. And I'm going to say as long as or while, okay, as long as or while the value of num is less than or equal to 10, I haven't completely printed my table yet. And so the condition here is always the condition when I want to stay in the loop. I don't want to quit yet. So it's the test for loop continuation. And so as long as num is less than or equal to 10, I want to print the value of num, its square and its cube, and add 1 to num. I could have said num plus plus here. This is another way to add 1. Num plus equals 1. And then when I hit the end of the while loop, I go back around. If that is still less than or equal to 10, I print that value and add 1 to num. So I keep going. Eventually, when num is 10, I'll print that last line. Num becomes 11. 11 less than or equal to 10 is false, and I stop. I break out of my loop. So here, I have only one system out println, but I get 10 lines of output. And you know what the great thing is about this? If I want the numbers from 1 to 1,000, I just change my condition here, and I will execute this one single system out println 1,000 times. How about that? So here's the table of the numbers from 1 to 1,000 and the squares and cubes. I can scroll up through here. You can see how this will work in the output window. So what's your favorite three-digit number? 671. This is the square of 671, and this is the cube of 671. Okay. Go all the way up here. So, okay. So I can get any numbers I want. If I wanted to start with 10 and keep going up until 200 and go up by 10 every time. Okay. Notice that I start with 10, then go 20, 30, 40, all the way to 200, and the squares and cubes. Okay. So repetition is a very powerful technique. You can solve, or you can process large amounts of data with very short programs. Okay, this is only a 1, 2, 3, 4, 5, 6 line little program segment, and I was going from 1 to 1,000, I got 1,000 lines of output. Okay, so we'll talk more about repetition as we move along here, but it's really an important concept.